All right, Chem 11, we are back. This is the next lecture in our series of lectures that deal with naming chemical compounds. All right? The number one most important skill you can have in Chemistry 11, or any chemistry course for that matter, is to be able to determine the name of a compound or the formula of that compound. All right? Now, formula determination, that's coming up down the line. Right now we're dealing with naming compounds. So if you see a formula, can you tell the name of it? All right? Again, names and formulas of chemical compounds, the number one most important skill. You have to be good at it to do well in chemistry. All right? There's no way around it. As usual, up here in the corner, we have the iPad with our PowerPoint lecture note, the same lecture note that I use in class, the same one that's on your D12 site for the course. You can print these off and should be making my notes your notes. So, the polyatomic ionic compound. Well, I see the word ionic, and that means that we're dealing with ions. We know ions have charges, and I know the rule for charges is the positive ion is first in the name and first in the formula, and the negative ion is second in that name or formula. All right? So what is a polyatomic ion? Well, a polyatomic ion is a cluster of atoms, right? It's a small cluster of atoms. Poly meaning many, and atomic meaning, well, made of atoms, right? So polyatomic means we have these small clusters of atoms that travel together as one unit. They're almost inseparable, almost. And overall, this small collection of atoms, this cluster, carries a charge, which makes it an ion. All right? Now, most of them are negatively charged. So they're going to take the place of whatever is second. So normally it was our non-metal, but most of them now are going to take this position. There are, however, very, very few positive ones. If we deal with one of them, and we will today, it will go first. So let's take a look. Now, on our PowerPoint, I have here, this is the list of polyatomic ions that you have to know from class. The same ones that are on that amazing hand-drawn poster. I know you don't believe me, but it's a hand-drawn poster that's in class. I've recreated that poster, only smaller, on this piece of paper. So you can see here, these are the same 8 polyatomic ions that you had to know in grade 10, and we have to know off by heart in grade 11. So we've got the name hydroxide, we've got the formula OH, and then the charge up here, 1-. And of course there's chlorate, nitrate, bicarbonate, carbonate, sulfate, phosphate, and ammonium. 8 of them. We have to know these 8 off by heart. All right, now, in grade 10, we were probably taught a little trick. And that trick came in the form of a statement, more of a mnemonic device than a trick. So let's take a look at that. We probably all remember this statement. Oh, Nick the camel ate a clam for supper in Phoenix. All right? Now, your teacher maybe didn't have this O at the beginning. I add it there because I use O for hydroxide. It actually follows the same rules as the rest of them. So what were those rules? Well, let's take a look. I'm going to erase this. And we'll put this here. All right. So let's take a look at something like the word Nick. Now, when I see Nick, Nick has 3 consonants, the N, the C, and the K. Nick starts with N, so Nick will start with N. The consonants are the number of O's. As we see, many of these polyatomic ions have numerous oxygens after them. This makes them oxyanions. Anions are negative ions. Oxy means they contain oxygen. These are all oxyanions. All right, you can see all of them have some non-metal usually and a number of oxygens. They also have a negative charge. All right? Nic helps me figure out nitrate. Nitrate and Nic both begin with N. So I take that first letter, boom, there it is. There's 3 consonants. The consonants, consonant, are the number of O's. Since there's 3, I know there's 3 O's in nitrate. And there's 1 vowel. I is our vowel. Put a line above I. The vowel is the charge. So the charge on nitrate, since it only has 1 vowel in Nic, is 1 minus. All right? So this is how this whole statement works. The first letter is the first letter of it reminds us of the first letter of the name of the polyatomic. The number of consonants is the number of oxygens. Nic has 3 O's. And the number of vowels is the charge. Only 1 vowel here, so 1 plus charge. So there's nitrate, and there's nitrate, right? We can do it with other ones as well, right? We'll do 2 more here just to prove that the rule works. So what about the word supper? Well, supper is sulfate. S, right? The S comes down. How many O's? Consonants. 1, 2, 3, 4. Boom, 4 O's. And how many vowels? 1, 2 vowels. That means it's a 2 minus charge, right? And there's also phoenix. Phoenix starts with P, so does phosphate. How many consonants? 1, 2, 3, 4. That means there's 4 O's. How many vowels? 1, 2, 3. 3 minus charge. All right? So that's how this whole little statement works. Now, if we underline the actual polyatomics that are in there, they kind of stand out. I've drawn them in larger capital letters. O is hydroxide. Nic is nitrate. Camel is carbonate. Clam with the Cl is chlorate. Supper is sulfate. Phoenix is phosphate. Now, notice I highlighted the word 8, right? That's because all of these words that I underlined in red stand for the 8th form of the polyatomic. What do I mean by that? When I use Nic, it gives me nitrate. When I use supper, supper gave me, if I can spell it properly, sulfate. And phoenix was phosphate. So this statement with the 8 in it is all of the 8 forms, except for hydroxide, which is the OH, and that's pretty easy anyway, but it still follows the rule. How many O's? Well, constants, 1. There's 1 O in hydroxide. What's the charge? How many vowels? 1. It's a 1 minus charge. So it still kind of fits, although hydroxide doesn't end in 8. All right? So that's how to use that rule. So let's continue. All right. Now, naming these things. Polyatomics get 2 names just like we do. They have a positive ion first, so whatever that happens to be, that will go first. Then the negative ion second, all right? As we saw on our list, most of these things are negative. Hydroxide, chlorate, nitrate, they're all negative. Only ammonium, the one below this orange line. Ammonium is the only positive one we have on this list. So if I'm using ammonium, it will go first because of this charge. All the rest of these will come in second in their respective names and formulas. All right? So the first name is the positive ion. Usually that will be a metal, or if it's ammonium, we'll use ammonium. The second name will be the name of the negative polyatomic ion. if we have a negative polyatomic ion. I might be using ammonium, and if ammonium is there, ammonium will be positive, and there might be a nonmetal here. Well, then we do the old shorten the name of the nonmetal and put IDE there. All right? So if our polyatomic is here, this will end in "ide," but if our polyatomic is here, we just leave it. We never, never touch the name of a polyatomic. So sulfate stays as sulfate. Nitrate stays nitrate. I do not touch the names of the polyatomic ions. All right? So here are some examples. I'm going to write them out in larger letters here. All right? Our first one, I'll do it in orange. Ca is calcium. All right? Calcium and SO4. Again, that's sulfate. Now, if I wasn't sure, I could use the word supper, right? Supper. I see the S, 4 O's, 1, 2, 3, 4 consonants. Its charge is 2, so this is sulfate. Because everything in Nick the Camel ends in 8. So it's calcium sulfate. The next one we'll do in green. This is potassium. K is potassium. And PO4 is phosphate. That's phoenix in that statement, but phosphate. All right. And then this last one we'll do in blue. We'll move it down here. This is ammonium, not ammonia, ammonium. And again, this is not a polyatomic. This is chlorine. It's by itself. It's just chlorine by itself, so it's chloride, right? Remember, I'd rather be alone. If chlorine is by itself, there's no O's here. It's just by itself. It's chloride. I'd rather be alone. All right? So those are the names there. Let's see. If it's online, it must be true, right? Abraham Lincoln said that. Now, we got to add the grade 11 understanding to this. If it was only as simple as that, eh? So, there's more than just one form of each type of polyatomic, which means nitrogen and oxygen, right? It can form nitrate like this, but it can also form other compounds. There's another one that's like this, NO2. They both have a 1- charge, right? So there's multiple variations of each polyatomic. So that's what this slide is dealing with. Now, I've enlarged this table to help explain that. So let me erase this and get that table out for you. All right. So here's that table right here. All right, I'm going to put it right here, nice and big, and then I'm going to write off to the side of it here. Where we're going to start is right here. All right? You can see we've got the root. Now, for example, we're using chlorate, right? Chlorate was clam in that statement. So it was Cl, 1, 2, 3 consonants, so 3 O's, 1 vowel, 1- charge. And because Nick the Camel ate a clam, right? Ate, A-T-E, I know this because it's in that statement, has to be chlorate. All right? Now, what does that 8 mean? The root is chlor because it can, it has chlorine in it. 8. That's the most common number of oxygens that chlorine and oxygen will have when the two get together. Let me rephrase that. When chlorine and oxygen get together to form a polyatomic ion, the most common ratio will be 1 chlorine and 3 oxygens. 1 chlorine, 3 oxygens. Whenever we have Cl and O together, this is the most common number of oxygens that we see. 3 of them, all right? Now, 8 doesn't mean 3. 8 means that's the most common form, all right? So, ClO3, that's chlorate. Chlor 8. That means the most common form for chlorine and oxygen in terms of making a polyatomic is one of these 3 O's. 1 chlorine, 3 O's. Now, there's another form. There's this. Now I keep the root the same. The chlor means chlorine is there. But notice this has 1 less oxygen than that most common form. This was my most common form. It had 3. This is 1 less. When I see that, it becomes ite. Chlorite has 1 less oxygen than chlorate, the most common form. This is ite, not ide. All right? Some forms have 2 less oxygens than the most common form. So even though we can't see it, we know there's a 1 here, which is 2 less than this most common form, which has 3. 2 less oxygens, and we add hypoite. This is hypochlorite. All right? Hypo is lower than. Just think, hypothermia means your body temperature is going lower than it normally should. If your blood sugar is lower than normal, it's hypoglycemia. Hypo means lower than. So I think of it this way. Hypochlorite is lower than chlorite. If chlorite was a 2, hypochlorite has 1 O instead of the 2. All right? And then the last variation. Sometimes we see where it has 1 more than the normal amount or most common amount of oxygens. And so again, our root is the same. It's chlor for the chlorine. And we put per 8. Perchlorate means 1 more oxygen, so here's 3 in chlorate. There's 4 in perchlorate. That per means more than. And I think of the word hyper. The end of hyper is going there. Hyperglycemic means your blood sugar level is more than normal, right? Hyperspeed means you're going faster than normal, right? Hyperactive, you are more active than normal. So perchlorate means 1 more oxygen than the most common form. The most common form was ClO3. Perchlorate is ClO4. Hyper. All right? So what we've just done is taken that table, of several polyatomics right here, and using this information, we've expanded it by 4. Right? There's a whole bunch more polyatomics out there now. All right? So, and this works, we can have nitrate and nitrite, sulfate, sulfite, hyposulfite, right? Phosphate, phosphite, right? So we can take that root and now expand it. The good thing is we can always work off the 8 form. The 8 form is a Nick the Camel. That's why Nick the Camel is so amazing, and it's all those 8s. And that's why in grade 10, we taught you all of the 8s. Look at all the 8s that are on this list. Chlorate, nitrate, carbonate, sulfate, phosphate, right? All of those 8s. So we taught you the normal or most common forms, and we can work off of those, all right? So let's go through a few examples here. Now, this slide just goes through a bunch. I'm going to bring it up, and then I'm going to work through a bunch with you, okay? And show you how we do it. All right, so let's take this, put it up into the corner. I'm going to erase this, all right, because I've got this up in the corner. And I'm going to put this statement right here, all right? I'm going to do a handful of examples for you so that we can see exactly what it is, okay? So let's do MgCO3. All right, Mg is magnesium. I don't change the name of metals. So magnesium. CO3. C is camel. Camel is 1, 2, 3 O's. The charge is 2. I don't need the charge here because I'm just doing the name, not doing formula. So CO3. Camel is carbonate. This is carbonate, right? All of these end in 8. There's my carbon. Carbonate is CO3. This is magnesium carbonate. All right? The next one, CaClO4. Ca is calcium. And now let's work this out. Get rid of that CO3. ClO4. Cl is clam. So Cl. 1, 2, 3 consonants is ClO3. This is chlorate. The thing I'm using is one more. That means it's per or hyper chlorate. Now I don't use the HY. It's just per chlorate. This has a 4, that has a 3. So I'm using my common form and then working off of my name. All right? Let's do a few more. My eraser does not erase too well. LiNO2. All right? So I know Li is lithium. All right? N, that's Nick. 1, 2, 3 consonants. NO3, these are the 8s. This is nitrate. Nitrate has 3. The thing I have has only 2. That's one less. That means this is nitrite. Lithium nitrite. All right? So I'm working off the common form to get me the next one. SrSO2. S is supper. 1, 2, 3, 4. SO4 is sulfate. Supper, sulfate. All right, so SO4 is sulfate. That's got a 4. What have I got? A 2. That's 2 less. So 1 less is ite, and 2 less is hypoite. So this is strontium, hypo, sulfite, not ide, hypoite. 2 less than the normal amount. All right, let's do the next one. K3, PO3. K is potassium. PO3, let's go to Phoenix. That's P, 1, 2, 3, 4 consonants means 4 O's. Phosphate is PO4, 8, PO4, I got it from here. This has 1 less, this is 4, this is 3. So this is phosphite, meaning 1 less, right? I'll underline my things. Let's do a few more. And the good thing is, if you work at these, you'll train your brain to recognize them automatically. All right? So, the next one, CuClO2. Now we've got a shifty metal. This could be trouble. So let's see. That's copper. I know I got to put a Roman numeral in there. And then I got to figure out the name of this thing. Well, we'll deal with the Roman numeral after. Cl. Let's do the 8, the chlorate version. So 1, 2, 3 is 3 O's. 1 vowel is a 1 plus charge, but 1, 2, 3 consonants. This is chlorate, right? Chlorate is this. Now, I don't use this. I'm only using what's inside the brackets. And we know we can't see it, but there's a 1 here. That's 2 less than the 8 form. These are all 8s. This is 2 less. So this is hypochlorite. Ite is 1 less. Hypoite is 2 less. And that's what this is when I compare these two numbers right here. All right, now that charge. Remember our zero-sum rule, right? So I'm going to draw this formula nice and big so we can use it. So the zero-sum rule. Remember, go with what you know. I got to figure out that charge. Well, I know I have 1 copper. I know I have 2 of these hypochlorite groups, right? That's hypochlorite. I've got 2 of them. The charge on hypochlorite. Well, the beauty thing about this is, if we look at this table, the charge doesn't change between the forms, right? Chlorate, chlorite, hypochlorite, perchlorate, they're all 1 minus. Same thing, sulfate, sulfite, hyposulfite, they're all 2 minus. Phosphate, phosphite, they're 3 minus. The charge number doesn't change. That's awesome. Because if I know the charge number on this, and I know the charge number because clam is 1, I know the charge on this is 1 minus. 2 times 1 minus is 2 minus. If this side is 2 minus, I know this side has to be 2 plus. 1 times what gives me 2? It's 2, so it's copper, 2 hypochlorite. All right, let's do the next one. The next one, PbSO2, 2. Oh man, another one that is shifty. So let's get the name done. Lead, Roman numeral, SO2. So I'm not sure what that is. Let's go over here. These are all the 8s. S is supper. 1, 2, 3, 4 consonants. SO4 is 8. That's 4. This is 2. This is 2 less. This is hyposulfite. Sulfite is 1 less. Hypo is 2 less with the ite. All right, so I got the 2 names here. I just got to figure out that Roman numeral. So let's go with what we know. I'll do it over here. So I want to figure out what that charge is right there. Go with what I know. I know I've got 1 of these. I know I've got 2 of these. And each of these, what's the charge on this? Well, the charges don't change. So the charge on this is the same as the charge here. The charge is the vowels. So let's go to supper because that's how we got this. 1 vowel, 2 vowels. The charge here is 2 minus, which means the charge here is 2 minus. The charge doesn't change between forms. 2 times 2 is 4 minus. If this side is 4 minus, this side is 4 plus. 1 times what gives me 4? It's got to be 4. So it's lead 4 hyposulfite. All right. All right. We'll do the last 3 since we started this. NH4, 2SO3. NH4, that's ammonium. We haven't seen the polyatomic come first a whole lot, but remember, ammonium is positive, so it goes first. SO3, go over here. 1, 2, 3, 4. 4 O's, right? 4 consonants, 4 O's. This is sulfate. Sulfate is 4. This is sulfite. It's got 1 less oxygen. Ammonium sulfite. Na3PO2. Na is sodium. Let's do this. Phoenix is phosphate. So 1, 2, 3, 4 consonants. PO4 is phosphate. PO3 would be phosphite. This is hypophosphite because it's 2 less than the most common form. Right? We're comparing those numbers right there. Hypophosphite. And the last one, we got through them all, is Ba is barium. SO4, hey, we worked that out just before. That's sulfate. All of these in here end in 8. And there you go. All done. Anyway, polyatomics can be challenging. I hope this makes it a lot easier in terms of naming compounds that have polyatomics. And if you're having any difficulty or have any questions, comments, or concerns, leave them in the comment section below this YouTube video. Or if you're in my class, reach out to me through EDSB. Or raise your hand in class because you just can't sit there and not know. I'll talk to you later. Bye-bye.